Hello class, let's learn about accuracy, precision and significant figures of your measurements through problem solving. Accuracy is how close a measurement is to a known or accepted value, while precision is how close repeated measurements are to one another. Let's look at this game. In the first case, the darts landed away from the bullseye and away from each other. That means this game has low accuracy and low precision. Let's look at this. And all the darts are landed very close to each other. However, they are far apart from the bullseye. So that means this game has a high precision but low accuracy. In this case, the darts are landed near the bullseye. However, they are apart from each other. So that means this game has high accuracy but low precision. So when you look at this, all the darts landed on the bullseye. That means this has a high accuracy, high accuracy and high precision. Let's do some problems. A student measures the mass and volume of an object 3 times in order to determine its density. All 3 trials were close to one another, showing good. If the measurements are close to each other, we call it as high precision. But he forgot to calibrate his balance, which affected if he forgot to calibrate his balance, these readings might not be correct. So it affected the accuracy. A student measures the mass of an object 3 times in order to determine its density. So these are the values: 25.9 grams, 25.5 grams, 25.7 grams. So when you look at these numbers, you realize these are very close to each other. That means these measurements show good precision. But he forgot to calibrate his balance and found that the actual mass of the object is 30.5 grams after the calibration. He concluded that the earlier readings have less accuracy. 4 students obtained following experimental values for ideal gas constant: 8.314 joules per mole per Kelvin. These are the values. First data is 7.215, 9.654, 8.912, 6.312. By looking at these data, you notice that these are far apart from each other. That means they have a low precision, and as well they are far apart from the real or actual value, and these data have low precision and low accuracy. So let's go to significant figures. So in this case, what we expect you to understand is you should know how to count number of significants in a measurement and do your mathematical operations. That means multiplications, divisions, and additions and subtraction, and round up your final answer to the correct significant figures. So first let's look at how to count your significant figures. So there are few rules you need to remember. So rule number 1 is all non-zero integers are significant. So this is an easy rule to remember. The problem comes when you are dealing with zeros, because there are several types of zeros you need to remember. So just one type of zero is leading zeros, and they are not significant. And there are in between zeros. If you see zeros in between full integers, those are always significant. Okay. And there's another type of zero we called trailing zeros. So if you see trailing zeros after a decimal place, those are significant. If you see trailing zeros, uh, if you see trailing zeros not after decimal place, those are not significant. As an example, if you look at 500, these have two trailing zeros, but there's no decimal place. So this number has only one significant figure. So let's go to these examples. So 236, those are all non-zero integers. So all three are significant. So if you look at this number, you have leading zeros. 1, 2, 3 leading zeros. Those are not significant. Only these full integers are significant. Three significant figures. So if you look at this one, this number has a zero in between. So it is significant. 1, 2, 3, 4 significant figures. So this number has trailing zeros. However, it doesn't have a decimal place. So these are not significant. In this case, we have 1, 2, 3, 4 significant figures. So let's look at this number. Always remember a trailing zeros when they are after a decimal place are significant. That makes this number to have 8 significant figures. So let's go to the problem solving. How many significant figures are in each of the following numbers? So this one have trailing zeros, but there's no decimal place. So this one has only 3 significant figures. Let's go to the second number, 0.0690. This one has two leading zeros and those are not significant. However, this zero is after a decimal place. That means it is significant. So we have 3 significant figures. So in this number, there's a zero in between that makes it significant. So this one has 5 significant figures in total. What is the answer to the calculation below when written in the correct number of significant figures? When you look at this question, you have to understand you have multiplication, addition, and division. So what you are going to do is you are going to solve this part first and then this part second, and you are going to add them later. The answer should be rounded to the same number of significant figures as the least precise measurement. So when you do, when you find the problem is, now you have to find the least precise measurement. How do you find the least precise measurement? If it is a multiplication or division, the least precise measurement is the one with least number of significant figures. If it is addition or subtraction, the least precise measurement is the one with the least number of decimal places. So don't get confused now. In this case, it's the least number of significant figures. In this case, it's the least number of decimal places. So let's do the question now. So we are going to get 2.029 times 0.053. Because this is a multiplication, we are going to count the significant figures. This one has 4 significant figures. This one has only 2 significant figures. So our final answer to go into this part is going to be in 2 significant figures. Let's go to the next step where you have the division. So in this case also we need to find the number with least significant figures. So this one has 4 significant figures, this one has 3 significant figures. So in this case, if you do the calculation in the calculator, this is the number you are going to get. So you have to round up to the correct significant figures. In this case, the lowest number of significant figures is 3. We are going to round this up to 3. Now in the third part, you are going to add these two numbers, 0.11 plus 7.36. When you do an addition, you have to find the number with the least number of decimal places. So this one has 2 decimal places and this one has 2 decimal places. So in this case, the answer should be in 2 decimal places. So this is your final answer. How many significant digits are there in the number 45.35505? So in this case, all the numbers are full integers except this 0. But this 0 is in between. That means it is significant as well. So you have 7 significant numbers. Write 10.178122 to 4 significant digits. So we are going to find 4 significant digits in here, and then we are going to round up, and that makes it to 10.18. Solve this operation and find the number of significant figures. So this is an addition. When we do the addition, we are going to consider the decimal places. So let's look at the decimal places in each number. So this one has 2 decimal places, this one also have 2 decimal places, and this one also have 2 decimal places. So our final answer is going to be in 2 decimal places. How many significant figures does this have? So in this case, you see trailing zeros. You have 3 trailing zeros. However, there's no decimal place. So these are non-significant. That makes this number has only 4 significant figures. Solve this mathematical operation, and this is addition. When you do addition, we are going to look for the least precise measurement. That means with the least decimal places. So you have 3 decimal places in here, 2 decimal places in this number, and 4 decimal places in this number. So our final answer is going to be in 2 decimal places. So this is going to be 144.60, 2 decimal places in the final answer. The mass of a beaker was measured 4 times. The masses were 87.987, 101.058 grams, 102.055 grams, and 100.095 grams. So we are going to consider now this is what is the average mass of the beaker. So sometimes you get confused when you calculate the averages. So remember that significant figures only apply to measurements. So you're going to find the sum of these and divide by 4. Still you have to look to the least number of decimal places when you add these up. So this one has 3 decimal places, 3 decimal places, 3 decimal places, and 3 decimal places. So your final answer is going to be in 3 decimal places. Remember, significant figures only apply to measurements. Round the following measurement to 3 significant figures. So in this number, you have a leading 0, which is not significant. However, these numbers are significant. Now we are going to round up the following measurement to 3 significant figures. So when you look at this, you have only 1, 2, 3 significant figures. How many significant figures are in the measurement 405.100 meters? So in this case you have two kind of zeros. One in between full integers, that means it is significant. Two zeros after a decimal place, that means those are significant as well. So you have total 6 significant figures. Subtract this by this. So when you have a subtraction, we are going to find the least precise measurement, which is the one with least number of decimal places. This has 3 decimal places and this has 2 decimal places. That makes your final answer should be in 2 decimal places. Solve the following. 4.220 meters times 0.10 meters. So this is a multiplication. When you do a multiplication, our consideration is the number of significant figures. So in this case, this one has 4 significant figures and this one has only 2 significant figures. So our final answer should be in 2 significant figures. Let's do another example which has a subtraction. When you do a subtraction also, we are going to consider the decimal places. So this one has 3 decimal places, this one has 2 decimal places. That makes you have to round up your answer to 2 decimal places. That makes the answer to 189.67. Let's do another example which has a division. So you are going to divide 100.89 grams by 25.5 cubic centimeters. It is the division and we are going to find the number with least number of significant figures. So this one has 5 significant figures and this one has 3 significant figures. If you divide by this in calculator, this is the number you are going to get. So we are going to round this up to correct number of significant figures. That means 3 significant figures. This gives you 3.96 grams per cubic centimeters. A piece of metal has a mass of 89.354 grams and a volume of 10.23 cubic centimeters. What is the density of the metal? So density equals mass over volume. So you're going to do the division between these two numbers, 89.354 grams over 10.23 cubic centimeters. This number has 5 significant figures and this number has 4 significant figures. So our final answer should be in 4 significant figures. So this is the number you are getting in the calculator. However, you have to round up it to 4 significant figures. And don't forget the units, grams per cubic centimeter. How many significant figures are in the measurement 1.3000 meters? So these are trailing zeros after a decimal point. So those are significant. That makes we have 5 significant figures in this number. When performing the calculation, the final answer must have, so for this is the addition and we are going to consider the decimal places. This one has 3 decimal places, this one has 1, this one has 2 decimal places. So the final answer must have just 1 decimal place. Excuse me. How many significant figures are in the measurement 0.00130 centimeters? So these are all leading zeros. However, this zero is after decimal point. These are not significant, while this one is significant. So that makes we have three significant figures. Let's do this addition. When you do addition, now you know we are going to find out the decimal places. 2 decimal places, 1 decimal place, and 3 decimal places. That means your final answer should be in 1 decimal place. So let's do a multiplication. So in this number, you have trailing zeros. When you have trailing zeros, and if there's when there's no decimal place, those are not significant. That makes this number has only 3 significant figures. So this number is all full integers. Those are all significant, 4 significant figures. When you do this math in the calculator, this is the number you're going to get. So, however, we have to round up this number to 3 significant figures. So, we're going to round up. In other words, in scientific notation, you can write in this way as well. So, this is the end of the problem discussion for the significant figures, and I wish you good luck. Please let me know if you have questions. Thank you.